final session is Liz Clark, also at the Northwest Fisheries Science Center, and she runs the groundfish program. And for those in the know, it also is FRAM. And some people even know what that stands for. So I'll give it over to Liz.
Okay, great. Well, our first speaker is Mary Ruckelshaus, and she's going to be talking about applying ecosystem-based management in Puget Sound, including the human element. And Mary's over at the Northwest Fisheries Science Center and is leading this EBM effort in Puget Sound, and is really, I was talking with her and looking at some of her CV, as you do when you want to introduce somebody, and she's getting back to her roots because her undergraduate degree was in human ecology from Stanford. So without further ado, Mary.
Yeah, thank you. I hope that doesn't make you think I have a credential in this topic. But also, I was thinking it's too many people. I really appreciate everyone coming in from outside in the sun. I was going to offer to buy people who showed up a beer, but I think it's a little out of my budget. So maybe Selina, you and I can split it. But thank you for coming inside.
That's great.
Okay, so I'm going to talk about what we've been working on in Puget Sound, and this is really the royal we. It's a lot of people working on this ecosystem-based. I think we've evolved from a fishery management to a management. It's a very young program, and so the human element, the way that it's included, is also very young. So I'll tell you the story, and I really have been privileged to listen to all these wonderful cases here the last couple of days, because the fishery management community has really done the human element in the best way. And so adding more sectors, which is what we're trying to do here, we have a lot to learn from you. So here's what I'm going to talk about today. I'll spend a very little bit of time, relatively speaking, on the first two parts, which I think we have, as we've seen the last couple of days, a lot of tools that we can use to include humans in objective setting, in terms of metrics and indicators, and also in evaluating strategies. So we do pretty well here, and I think this is the part here, because of how young our program is, that we have a bigger challenge. So that's kind of the overall theme of my talk. So in this region, I'm sorry, for those of you who aren't from around here, we are right here. So this is the Pacific Ocean, this is the Strait of Juan de Fuca, this is British Columbia up to the north, and this is the Puget Sound Basin. So we have the Olympic Mountains here and the Cascade Mountains here. So it's a sort of almost an inland sea that we're talking about. And because of that, the mountain ranges on either side, we have a system where there's a lot of marine species, a lot of highly migratory species like orcas and salmon, and then also a lot of land-based activities that are impinging on this system. So the big causes of concern that really spearheaded this effort that I'm going to talk about have to do with declining iconic species like orca and salmon. Rockfish were recently proposed for listing. And then closures of the local salmon. You can't eat more than several a week because of toxic contaminant concerns, shellfish bed closures, and then problems with freshwater flows. So these were the red flags that really caused for these calls for ecosystem-based management. This is my one slide, and in just talking at lunch with our authors group, this is really more commensurate with some of the other talks we've heard the last couple of days, where we did a big effort to do an ecosystem-based fishery management planning system in Puget Sound. I'm really not going to talk very much about this, but it involved many, many stakeholder groups, many sectors, and there are numerical targets that were established for what would a viable group of salmon in this region look like. So there are numerical targets and strategies that were adopted and developed into this recovery plan. This process that was developed, it's multi-sector. It's some governments, some tribes which have treaty rights here, and a lot of stakeholder groups, is now what has evolved into a broader scale effort called the Puget Sound Partnership. And this was started by Governor Gregoire about a little over 2 years ago, and she has called for a recovered Puget Sound by, guess by when, 2020. What she really clearly said was thriving natural and human systems. So she, in her vision statement, stated that this thriving system had to include humans and the natural part. And in their first year, by legislative mandate, they produced their ecosystem plan. She didn't like the word plan. She thinks we plan too much around here, so they called it the action agenda. But it essentially lays out the objectives and priority strategies for this first 2 years of implementing their plan. So as I said, it's brand new. So the charge then that they have adopted and agreed upon for themselves is to recover not only the natural parts of the system, including the upland watersheds and out to the pelagic waters, but also the human element. So there are very explicit goals stated that include humans as well as the natural system. So for the people who compare these lists and these principles for EBM, actually the situation here looks really good on paper. And that gives us some heart, but it's also, when you see what we've actually done with it so far, you can see how challenging it is. So we do have a legislative mandate which states that the ecosystem will be recovered by 2020 and that it mandates multi-sector management. There has been this 1.5 year long scoping step to agree on multiple objectives, so not just fisheries for salmon and ground fish, but also a whole bunch of other things like clean water and some human well-being measures that I'll show you in a second. So including both humans and natural systems, and they actually mention by name that the framework they want to use for these metrics is ecosystem services. And then it's a clearly outlined governance structure and process for the management of this that I can talk more about later if you want. How it's implemented is really remains to be seen, but at least the way the structure is set up, there's a lot of governance boards, there's a science panel, it's very well clearly laid out in this legislation. So to build their ecosystem plan, what the partnership staff did initially was pose 4 questions that would guide their ecosystem planning. And these are listed here. It's really a definition of what is healthy. First, where are we now in terms of the status of these indicators? And then where do we want to be in the future? They've articulated in narrative terms. And then the last 2 questions are really what will it take to achieve that future vision and where should we start? So these are the organizing principles in the plan, and they've been answered to the best of their ability in a year-long process. And I just wanted to mention, I'm not going to talk about this more, but underneath those 4 questions is a formal IEA that's going on right now in Puget Sound. So NOAA has agreed to have one of its first integrated ecosystem assessments be piloted in this region. So we are, Phil Levin and I are leading this effort with a whole bunch of other people. We are implementing an IEA within the region to underpin the answers to those 4 questions. Okay, so I'll tell you now one of the sets of examples of, now these are really just highlights and they're examples. The reason I picked the examples I did for both indicators and strategies is that these are new analyses that were actually stimulated by the policy questions that came out of this partnership effort. So there's been a lot of previous work done before this, but these are analyses that when the policy questions were posed, given this broader framework from the governor, that were actually instigated recently. As I mentioned, the first thing that this partnership group did is to go through a 1.5 year long scoping process to identify when the governor says human and natural systems, what do those goals look like and how might we identify what those objectives are. So those are narratives written in their ecosystem plan. Now, to identify indicators, again, they had to do this in their first year of existence. So they did really what all they could do, which is do a lot of polling and interviews of people in this scoping process to talk with them about what do you care about, how might we measure human and natural system health in this area. And then I'll talk about a quick example of some other work they did to screen a set of existing indicators and some new modeling. Okay, so here's one sample of some polling that was done in this region. So you can't read this, and I don't expect you to. These are the ecosystem services as listed in the Millennium Ecosystem Assessment. Since the partnership agreed those were sort of the general currencies they wanted to use to indicate health of the system, a group of sector representatives, so these are all sectors, so we have ports and shipping, business, home building, tourism, fishing and aquaculture, forestry, ag, recreation, and then county, local, tribal, and federal governments and NGOs. So people from each of those sectoral representatives were asked which of these services are most important to you. And since you can't read them, the ones in green are capture fisheries and aquaculture and water purification. Those were the top group of the most important services across the sectors. You can see the ones that are shaded are the ones that each sector said was most important. The blue is also top. Actually, I think green might be what they called tier 2. It's really water, freshwater quantity and water regulation. And down here, recreation and ecotourism, which are very important in this region, and ethical and existence values, which were important to every sector except for ports. And I never went back and asked the ports why they didn't care about ethics and existence values. I think that's probably an error in the questioning. So this was part of the information that the partnership used to say, okay, these are some of the important indicators of human well-being in this region based on this very cursory interview analysis. The other thing they did in their first year, so I want you to remember this is the first year, so these are all very sort of quick and dirty kind of analyses, is they screened existing indicators in the region using a National Academy report and the Heinz Center reports and reports that have been done on what makes a good indicator. And they applied these criteria and came up with a list of from about 500 or 600 things in this area that are being measured that have to do with one of their 6 ecosystem goals. They came up with these screening criteria and went on it down to over 100. And that's not including human well-being. So they were successful in winnowing down an unwieldy list to a somewhat less unwieldy list, but they still have a lot of indicators that they have to sort through. These are some of them just to give you an idea of the diversity. We have mountain goats, and we have unemployment, and we have sense of place and everything in between. So this is the list, and there's some discussion about what do we do with this now, and was this the best way to do it, but this is what happened in this first year. There's now, to give you an example of the kind of modeling that has been stimulated by this process that is actually new and is turning out to be really promising, is some work that Jamil Semhuri and Phil Levin have done using the EcoPath with EcoSim models. They've taken 6 models from this North Pacific region that already existed, and they did a series of perturbation experiments with the model and asked how when the system changes, what we really want to know, they argue, for indicators of ecosystem function are these emergent properties, these attributes that are actually very difficult to measure directly. So in this case, it's the health of a human. And the indicators are things like a blood pressure or temperature, so things that you can actually measure. So using this series of looking at all these different perturbations to 6 different EcoPath models from this general broad North Pacific region, they have identified some relatively informative broad indicators. So here's just one shown here, this benthic invertebrate biomass. In all of these models was fairly responsive as you change this indicator here, the attribute that you're more interested in. So here's one that's biodiversity, here's food chain length, and here's nutrient cycling, that these actually are responsive to changes in benthic invertebrate biomass. So this is a pretty good indicator for that relatively fuzzy attribute. Also informative in this whole exploration they did are things like phytoplankton and jellyfish. And some things that we actually measure now but aren't as useful in indicating these attributes are total catch biomass in seabirds. So as a summary, from these different models, these are the attributes that they really just looked at from the literature, and this is a lot of Beth Fulton's work as well, has identified. These are their attributes of ecosystems that have been found to be of interest to people in different management contexts. And these are the indicators that pretty generally came out as being strong. And then what you can do with these is look at them in trade-offs like Tony showed yesterday in these kind of spider web diagrams. So if you look around the edges of this diagram, here's one of the human well-being indicators on here. And you can look at different perturbations that you make to the model. So here's one that's no fishing, and you can see what of the indicators, what levels are reached. And then in these other perturbations, a trophic level threshold has been breached, and in the dark purple, all of the ecological thresholds have been breached. So using these different perturbations, you can see how the indicators themselves change and what those trade-offs are. So these are really useful and tractable approaches you can use to look at and highlight these trade-offs with models that already exist for this area. This has not been incorporated yet into the Puget Sound management structure because these analyses started at the beginning of their year process, and their year process, you know how it goes when you make a report, you have to finish it within 6 months of publication. So this will be entered into the next iteration of the overall process. Okay, so we talked a little bit about that. I'm going to give you one example of some models that have been initiated to evaluate strategies. So what the partnership did, again, given this year time frame, is they went around to the regions they call action areas. These are kind of governance regions within the area, and asked them, through this rather bottoms-up process, what priorities have you already identified for your region for any of these 6 human and natural system goals? And they did this process for this first year to winnow down, again, their lists of priorities that have come about. Many of them came from the salmon ecosystem planning that we talked about briefly, and then others for water quality and other species. And they came up with a list. And then there's some other examples that we're doing right now that's kind of more systematically looking at how do you put together multiple objectives into one management strategy. So here's an example of the bottoms-up, just compile what do we already know from this priority strategies. And these are the 4 areas that the partnership came up with in this first year. So protecting intact areas, restoring critical places, and then stopping land-based pollution, and then this one they call fix the system. So that's basically get all these sector management and jurisdictional issues that many of you have been talking about to work better. So these are just examples of the kinds of actions, very specific places, land-based pollution efforts, and then a lot of different protection focuses. Okay, so now the modeling, for example, that's been done, this is work that I've been doing with Ann Gary and Mark Plummer, is really remembering that the partnership is very interested in using ecosystem services and valuation of those services to help them think about what sort of decisions should they be making that are different. So we're using this decision approach, and most of the stuff we've been hearing about the last couple of days are these biophysical models where you ask, if you change a system, how does a service like a fishery change? In some of the cases we've had value estimates. So we're using this general approach to look at one of their main management issues and their priorities, which is if we want to change in protecting or restoring nearshore habitats such as these eelgrass habitats along the shorelines, what would be the consequences of those strategies for, instead of just one thing, a whole bunch of things. So a whole bunch of ecosystem services in this case. So looking at harvest, looking at abundance of species that people can watch for wildlife viewing, carbon storage and sequestration, and then the ability of this nearshore habitats to break down toxics or to purify the water. So what we've done really simply, I'm not going to show you the results, I'll just walk you through the decision framework. So we've looked at things like where to put gooey duck farms or where shoreline hardening can occur. Those are the kinds of actions that then affect the distribution and quality of eelgrass habitats, and therefore the success or the abundance and biomass of Dungeness crab, which is a big commercial fishery in this area. They rear there as juveniles. That can then lead to estimates of landings and market production of the crab, and then the revenues from the crab fisheries. And then Mark Plummer's worked with an input-output model to not only say how many dollars result from crab landings, but also what about the ancillary effects on other sectors of the economy. So where do those dollars flow? It's sort of like when the Super Bowl or the Olympics comes to your city, what are the dollar ramifications for that? So here's an example that Mark ran through with some of the biophysical model results. So if we improve nearshore habitats, that can give rise to an increase in a 5% per year, one of the scenarios, in young of the year survival of the crabs. That increases the Dungeness crab harvest by 4 million pounds. And then you can put this into the input-output model and ask not only how many more jobs are created directly in that sector, so in this case we get 91.8 more jobs of crabbers, but also what happens to where they drink their beer, where they go to the doctor, and where do they buy their houses. So overall, it's about 100 more jobs from that amount of improvement in Dungeness crab survival. This is pretty back of the envelope, but it gives you a rough sense of how to look at not only the consequences of nearshore habitat for a fishery, but also other sectors in the region. So what about marine harvest and food web support? What happens to the other species that we might be interested in? So a big one are herring. Well, I just talked to you about crab as an example. Herring also rear in eelgrass habitats, and they're a key forage species in the food web. So we used, again, an EWE model to look at if you'd improve or increase eelgrass biomass within this model, then the relative biomass of a number of these groups, these might be hard for you to read, it just shows some more trade-offs here where this purple line are pinnipeds, so that includes orcas and marine mammals such as seals, harbor seals, and porpoises. So these are things generally that people like to watch for wildlife viewing. But unfortunately, Pacific hake, which is a species of concern in this region, declined. So here's an example of another trade-off that these kind of models can elucidate and help people think about, well, what do we want to put in terms of strategies for nearshore habitats, and can we put some of these restoration projects in areas that can benefit the species we want to and mitigate losses against others. So what this sort of general ecosystem services framework modeling gives us is really a way to ask a pretty straightforward question, which is where do we protect or restore a nearshore habitat, and ask for a whole host of services, so Dungeness crab landings and some of the economic consequences of that, herring as a forage fish and the species trade-offs there. And then we've also done estimates of carbon sequestration and phytoremediation. And it helps people look at the multiple consequences for a lot of services about a certain action, which is just one of the many that the partnership's looking at. Okay, so this slide I actually had in here, but I think it really harkens back to Simon's point yesterday, which is this is exceedingly complex, what I just explained to you. And human brains, I don't know if many of you saw the New York Times Magazine article last weekend, but they talked about how human brains can process or not information about risk and why it's so hard for us to think about climate change. And it's basically because the risk horizons that science gives us, our brains cannot compute. It's too far into the future. So what I really want to close with is this last part, which is how do we simply communicate and translate science using a lot more, I think, really lessons from the fishery examples that we heard, where we use rules of thumb derived from pretty complex models, but simplify it down to just principles and really just decision rules that are not a lot of that complexity that I just showed you, but that are based on sometimes pretty sophisticated models. So one thing, I'm going to give you 3 quick examples here. One thing that we're doing is moving towards synthetic documents. We're really modeling these after the IPCC process for the assessments, the global assessments. So we have synthetic review papers that are being commissioned right now that will write down what do we know about the system here. And they'll be peer reviewed and they'll be put on a wiki type interface so that the turnover and peer review process can get the content out there quickly so we don't have to wait for another 5 years for the next assessment. So this is one thing that we're doing to help get the science information translated quickly into the decision process. This just shows one of the examples of these clickable wiki sites. As someone mentioned yesterday, having Microsoft in town helps a lot. So you can start simple, and depending on your level of interest, you can go deeper and deeper and get into actual data and documents if you're interested. Okay, the second example is this translation. The translation problem is a big one, and I think we're trying to get most people over here. I really hope people don't stay in this part of the diagram. It's possible that there are people who will get it, but that realize there's nothing to get, that we have to give them that. But I think the real challenge is just this, taking the time to translate what we know for people who actually can use it within decisions. And this isn't going to be for everybody, but if more of us did this, it could really help get the information into the decision makers' hands. Okay, and the last example I want to show you is something that we've just started talking about with really focusing on the human use of the system. So people like to use this area directly. And I'm going to show you a series of 4 maps that Mark Plummer, who I think is in here, put together. So just look at this region. This is, again, we're here in north central Puget Sound. So here's one indicator of how humans use this system, and this is just pounds of harvest within the region, and you can just see some of the regional differences. A lot of shellfish are landed in the southern part. It's very diverse up in the north in terms of the species that are landed. Here are revenues from those landings. Again, South Puget Sound and Hood Canal just crank out revenues from shellfish. A lot of salmon in the central area, and a lot of Dungeness crab revenues up in the San Juans. Here's shoreline access. So this is, again, where people can go and access the habitats. San Juan Islands has the greatest water access, and you can see it's a lot of private access throughout the rest of the region. And the last one I'll show you is recreational shellfish. So Hood Canal is, again, it's a big recreational area, and a lot of different shellfish species are generated there, and quite a diversity up north. So what we've been thinking about doing is getting a regional identity for these areas. These are real. So these, I did not make these up. So these are sayings from, these are the themes, the city mottos for each place. And what you can tell is you need the name and then a colon, and you need an exclamation point. That's all you really have to know. But Bellingham, of course, does not have an exclamation point. So what we want to try to do, I think, is if we're thinking about the future vision of this system, we want to get them to have identities and think about their future role in what is this recovered state going to look like. So, and clearly I'm not the person to do this, but I did make a stab at it based on those maps that we just saw. So for those of you who aren't from around here, Washington's playground up here, this is good because this is where all the mountains and the water are. Whidbey Island actually has the biggest population of liberal arts educated retirees, so I thought we should have a little French in there. There's a lot of recreation over here, if you'll remember, and there's a lot of really good working families over there, so they kind of like to dig and eat. We might keep the Seattle handle there, and then the gooey ducks in South Sound. So what I really think this could do, if we think about this, is maybe the lack of a win-win possibility in Puget Sound could be a little more plausible if we think not of trying to maximize human well-being and natural system functioning in each place, but try to partition it and do some spatial management. So to close, I just wanted to say that I don't think that this communication is for everybody, and if you think about trying to do a tweet and you might be someone who's kind of like the person on the left, then that's not really for you to try to do this boiled down simple communication and do rules of thumb. But if you're more like the person on the right and you have to limit yourself to 140 characters, then come talk to me because we need more of you. So thanks.
Time for a question?
Yeah.
It's one of the few examples that I've seen where restoration is actually part of the equation, and does the time course that you guys have established for completion of the project, I guess 2020 is I guess what you said?
Yeah.
Is that consistent with the objectives of restoration? In other words, can you do restoration in that sort of short time scale that will, you think, accomplish the goal that you're after?
Yeah, so the question is, can restoration really achieve goals by 2020? And I think it's pretty clearly the answer is no. Some people scoff at the governor's 2020 timeline. Others just say, well, let's see what we can do by then. And what the partnership has decided to do is there are not yet any numerical targets for any of those indicators of ecosystem health, except for salmon and a handful of other elements. So they have human health and well-being and a lot of other goals and clearly stated objectives where they're not setting targets yet. And they actually want to do that. They want to set benchmarks that where will we be by 2020, and they're doing that this year. So that question will be met head-on this coming year, where they'll try to say how far towards a functioning nearshore can we get by 2020, and what will those numerical targets be? So they haven't really wrestled with that yet, but that's where they're gonna try to figure that out. I think no scientist is really thinking that those can come to fruition by 2020. So the question is how far away from current conditions can we get towards the recovered state? Yeah.
One more quick one. So there seems to be perhaps a gap between the excellent work that's been done so far and the great idea of basically creating identity and vision around kind of the community identity and going with various, as you said, partitioning the management that way. When you look at the whole idea of land-based sources of pollution, that's where the gap seems to be, because that's people's everyday behaviors. So what are some of the ideas for addressing that gap? And I'll just throw out one idea, the recent research that's revealing the amount of toxics that's coming off of individual automobiles.
Yeah, okay, and maybe we can talk more about this during the panel, but one quick response to how do we reconcile human use as impact and identities for the different regions is that if, for example, shellfish harvest, if South Sound or Central Sound wants to become the engine for shellfish beds for recreational and commercial fisheries, then those areas would be where the focus for reducing toxic runoff and pathogen runoff into the Sound to support that wild and aquaculture shellfish would really be targeted. So what we're thinking is it would be a useful first filter to say, well, the role of this region is going to be a shellfish generating area or recreation or whatever it's going to be, and then target the strategies to first achieve those sort of key sectors and then address the other issues, because the list is long of things to do. So that's one idea, but we'll see how it goes.
Well, we'll wait for other questions for the panel discussion. Thank you.